Profesor, a continuación voy a exponer mi parte del segundo informe de cálculo. Dice así: Problem 5. Find a twice continuously differentiable function f or reals to 0 and plus infinite satisfy double if double prime of x times f of x is greater than or equal to the to 2 times if prime of x equated for all x in the reals. Solution: we shall to show that only positive constant function satisfy the condition. Is g of x equals 1 over x on x of x. Notice that g doubled prime equals the second derivative of 1 over f equals the derivative of negative if prime over f equals the derivative of 2 times f prime equated minus f double prime times of over f cubed is less than or equal to 0. Take to arbitrary reals nomen a greater than b be the concavity of each g for all u greater than and b minor than b will have g of a minus g of u over a minus u is greater than or equal to g of b minus g of a over b minus is greater than or equal to g of b minus g of b over b minus b. Combine this with g of u is g of b minus greater than 0. We had g of over a minus u is greater than or equal to g of b minus of over b minus is greater than or equal to negative g of b over b minus b. Now be taking limit u to minus infinite and b to infinite, we obtained 0 is greater than or equal to g of b minus g of a over b minus is a is greater than or equal to 0. So g of a equal g of b. This old for any pair I b, so g of x is constant, and f of x equal 1 over s g of x else is constant if f is constant, then f prime equal f double prime equal 0, so the condition is satisfied. Remark, instead of the function over your 1 over if of x, the same idea works with la cotangente, if of x al cotangente f to f of x, the second derivative of al cotangente f of x equal g f double prime times 1 plus f equaled minus 2 times f prime equaled over 1 plus f equaled f double prime times 1 plus f equaled minus 2 times equaled double f double prime time minus 2 f prime equaled 2 times f prime equaled over 1 plus f equaled is greater than equal to 0. Is as can be seen al cotangente f of x is a bounded convex function, therefore is must be constant. Gracias, profesor. Eso es todo. Pues ahora voy a comenzar con la siguiente parte, que es exponer un caso, una aplicación en la vida real. Y así, a notable historical example of the importance of prime numbers and asymmetric cryptography is implementation and use of RSA in data security from its invention in the 15 no is 1929 70 to the present. RSA have been widely adopted in computer security and communication application, ensure the protection of critical information in various industries and sectors. Engineers use mathematical and computational tools to optimize the average descent, ensure that the function f of x describe the deformation complete with the safety constraints and performance established by inequality. Gracias, profesor. Lamento la pronunciación. Muchas gracias.
Ok, profesor, voy a exponer un problema que nos ha dejado sobre el IMC 2020. Voy a pasar a exponer lo que es el problema número 2. Let A and B be a n for n real matrix such that RK multiplied AB minus BA plus E equal 1, where is the n for n entity matrix. Prove that trace 8b AB minus trace 8 elevate 2 for b elevate equal 1 minus 2 n 4 n minus 1. The solution for this is let x equal AB minus BA. The first important observation is trace x elevate 2 equal trace AB minus ABBA minus BAAB plus BABA equal to trace ABAB minus 2 trace A elevate 2 B elevate 2 using that trace is cycling. So we need to prove that trace x elevate to 2 equal to n for n minus 1. By supposition, x plus 1 has rank 1, so we can write x plus a equal b elevate 2w for 2 second vectors. So x equal to bt w minus a elevate 2. An alternative way to use this rank 1 condition is integrand size x plus a, and rank is an elevate 0 with multiplies 8 minus 1. So x has in revelation minus 1 multiplied minus 1 since trace I the remaining integrand value of x must be n minus 1 hence.
Okay, a real example where matrix and their specific properties play a crucial role is in the Shor algorithm and quantum algorithm developed by Peter Shor in 1994. This algorithm is capable of acting large integers efficiently, which has direct implications in the cryptography and information security. The formation of matrices in Shor algorithm, quantum transformations are used that can be represented by unit matrices. The efficiency of the algorithm is based on applying these transformations in a way that exploits the properties of superpositions of quantum entanglements.
Hello, my name is Giancarlo Gutierrez Blas, and I am going to expose the problem tree, and it says, let d greater than or equal to 2 be an integer. Prove that there exists a contact C of d such the following holds for nx convex polytope k subset of R to the power of d, which is symmetric about the origin, and any epsilon in the open interval 0 to 1. There exists a convex polytope L subset of R to the power of d with a most C of d times epsilon raised to the power of 1 minus the vertices such that 1 minus epsilon times k is contained in L and L is contained in k. For a real alpha, a set subset of R to the power of d with non-t integer is a convex polytope with the most alpha vertices. If t is the convex of a set X subset of R to the power of d of at most alpha points, that is, t equals the sum over x in x of t sub x times x, where x times x where t sub x is greater than or equal to 0, and the sum over x and x is of t sub x equals 1. For a real lambda, put lambda times k equals that set of all lambda times x such that x is in k. A set subset of R to the power of t is symmetric above the origin if negative 1 times t equals t. The first solution is in elementary terms, and it says, let p sub 1 to p sub m be an inclusion maximal collection of points of the boundary k of k such that homothetic copies k sub a defined as p sub I plus epsilon over 2 times k have these points integers. We claim that the convex hull L denotes as comp p sub 1 to p sub m satisfies all the conditions. First, note that by the convexity of k, we have a times plus b times k equals the sum of a and b times k. For a and b greater than 0, it follows that k sub I is contained in 1 plus epsilon over 2 times k. On the other hand, if k is in k are greater than 0 and ak is in k sub I, then p sub I in ak minus epsilon over 2 times k, which equals ak plus epsilon over 2 times k, contained in C a plus epsilon over 2 times k. And since p sub I is a boundary point of k, we get a plus epsilon over 2 greater than 1, a greater than 1 minus epsilon over 2. It means that all k sub a lie between 1 minus epsilon over 2 times k and 1 plus epsilon over 2 times k. Since their interiors are disjoint by the volume counting, we obtain m times epsilon over 2 raised to the power of d is less than or equal to 1 plus epsilon over 2 raised to the power of d minus epsilon over 2 raised to the power of d is less than or equal to 3/2 times d times epsilon. Since f of f epsilon equals parenthesis 1 plus epsilon over 2 raised to the power of d minus 1 minus epsilon over 2 raised to the power of d is a polynomial in epsilon without a constant term with non-negative coefficients which sum up to 3/2 times d minus 1/2 times d. Therefore, m is less than or equal to 3 times d times raised to the power of 1 minus d. It's clear that L is contained in K, so it remains to prove that 1 minus epsilon times K is contained in L. Assume the contrary. There exists a point P in 1 minus epsilon times K, but not in L. Separate P from L by a biplane. Choose a linear functional backtrick such that backtrick of P is greater than or equal to the maximum over x in L of backtrick of x equals is maximal possible. Note that by our construction, x plus epsilon over 2 times k has a common point with some k sub I. There exists a point in the intersection of x plus epsilon over 2 times k and p sub a plus epsilon over 2 times k. We have backtrick of p sub a plus epsilon over 2 times a is greater than backtrick of c is greater than backtrick of x minus epsilon over 2 times a, and therefore backtrick p sub a is greater than a times 1 minus epsilon. Since p is in 1 minus epsilon times k, we obtain backtrick p is less than or equal to a times minus epsilon, a contradiction. And the second solution in the language of Banach species, it says equip r to the power of d with a norm k dot k whose unit ball is k. Call this Banach space 5. Choose an inclusion maximal subset of the boundary of k whose pairwise distances are greater than or equal to epsilon. Put L equals the convex hull of x. The inclusion of L in k follows from the convexity of k. If the inclusion of 1 minus epsilon times k in L fails, then the Banach theorem provides a unity linear functional lambda in the dual space 5 stars such the maximum of lambda applied to L equals the maximum of lambda applied to x, which is less than or equal to 1 minus epsilon. Then the point x in k where the maximum of lambda applied to L equals the maximum of lambda applied to x, which is less than or equal to 1 minus epsilon. Then the point x in k where the maximum of lambda applied to equals 1 is attained thanks to the finite dimension and compactness is on the boundary of k, and as lambda witnesses at a distance greater than or equal to epsilon from all the other points of L and x, contradicting the inclusion maximal of x. The upper bound for the cardinality of x is obtained by noting that epsilon over 2 balls centered at the point of x are pairwise disjoint and lie in the difference of the ball 1 plus epsilon over 2 times k minus 1 minus epsilon over 2 times k, whose volume is 1 plus epsilon over 2 raised to the power of d minus to 1 minus epsilon over 2 raised to the power of d. Hence, the cardinality of x is less than or equal to 2 plus epsilon raised to the power of d minus 2 minus epsilon raised to the power of d over epsilon raised to the power of d equals 0 times epsilon raised to the power of 1 minus d. Thanks.